Hello dear students, you are welcome again on our YouTube channel of Shri Saraswati Bhuvan Education Society Chhatrapati Sambhaji Nagar, and here we are studying the subject General Science chapter number 5 inside the atom from your textbook of class 8. So this is lecture number 2. In the earlier lecture we have studied so many interesting things which were regarding the atom. So today we are going to see the next part, that is nothing but the atomic structure. So here I would like to share with you when we consider any atom, an atom is formed from the nucleus and the extranuclear part. Here you can see at the center it is the nucleus which is situated there, and the exterior part which is called as the extranuclear part. So firstly I would like to explain the nucleus. Always remember, the nucleus of atom, it contains two subatomic particles, or which are called as the nucleons. They are nothing but the protons and the neutrons. Firstly we will see what are the protons. Remember, proton is positively charged subatomic particle which is present in the nucleus of atom, and the positive charge on the nucleus is due to the proton which are present in it. Remember, the proton is represented by the symbol P. Well, each proton carries a positive charge that will be equal to plus 1e. If we want to know what is 1e, 1e is the charge which is equal to 1.6 into 10 to the power minus 19 coulomb. So when total positive charge which is present on the nucleus, it is expressed in the unit E. And if we consider the magnitude of that charge, that will be the number of protons which are present in the nucleus. So the number of protons which are present in the nucleus of atom is the atomic number of that element, and we denote it with the symbol Z. So if we consider the mass of proton is approximately 1 Dalton. Again, what it mean by 1 Dalton? Remember, the 1 Dalton is 1.66 into 10 to the power minus 27 gram. So the mass of one hydrogen atom is approximately 1 Dalton. So generally we compare the masses of another atom with the hydrogen atom. Now I would like to tell you about the neutron, which is the another subatomic particle, or one can say the nucleon, which is present in the nucleus of atom. So here I would like to share you what is the neutron. Neutron is an electrically neutral subatomic particle, and it is denoted by the symbol N. Here the number of neutron in the nucleus is denoted by the symbol capital N, and always remember, the mass of one neutron is approximately equal to the mass of proton, that is equal to the 1 Dalton. So here we saw what is the nucleus of atom. I told you right now that entire mass of any atom, it is concentrated in its nucleus. What it means, if we consider a cricket ground, we will compare a cricket ground with an atom. If we see the cricket ground, you may imagine how much big is the cricket ground, and I put a ball at the center of a pitch. So when we compare any atom and the nucleus of it, so remember, entire mass of that ground size atom will be concentrated in a ball size nucleus only, and the ground, that means the greenery or the grass which we see in the cricket ground, will be the extranuclear part of that atom. So you can conclude that how much concentrated nucleus is present in any atom. Now I am talking about the extranuclear part of atom. Extranuclear part in atomic structure, it includes the electrons which revolves around the nucleus, and there are some empty spaces between the nucleus and the electron. So now I am going to talk about the electrons. Electron is a negative charge subatomic particle, and it is denoted by the symbol E. Each electron, it carries 1 unit of a negative charge, and remember, the mass of electron is 1800 times less than that of mass of hydrogen. We saw that in the atomic theories also. In the Thomson's atomic theory, he told that there is a negatively charged particle which has the 1800 times less mass than that of mass of hydrogen. So it is nothing but the electron. Electrons, they are present in the extranuclear part. They revolve in the discrete orbit around the nucleus, and the orbits being three-dimensional in nature, a term shell is used instead of term orbit, and the energy of electron is determined by the shell in which that electron is present. What it means? Any electron, if it is present in a specific orbit, the orbit it contains a specific amount of energy level. So if electron has to stay in that orbit, then that electron should possess that much amount which is equal to the energy level of that particular orbit. So the number of electrons in the extranuclear part is equal to the number of protons which are present in the nucleus of atom. So earlier we saw that the atom is electrically neutral species. Again we know that the magnitude of the positive charge which is present in the nucleus, that means the proton, and the magnitude of negative charge on the electrons is the same, as the number of protons present in the nucleus and the number of electrons which are revolving around the nucleus is the same. Therefore they neutralizes each other. Therefore atom is electrically neutral one. Here we must take one thing in consideration, that the mass of electron is negligible as compared with the mass of proton. So when we consider the mass of any atom, we consider the mass of protons and neutrons present in its nucleus instead of taking consideration the mass of the electrons. So total number of protons and neutrons in the nucleus, they determine the atomic mass of that element, and the atomic mass is denoted by the symbol, it is capital A. So here we come to the conclusion that the atom is electrically neutral. It possesses three types of subatomic particles: protons and neutrons present in the nucleus, electrons are present in the extranuclear part, they revolve around the nucleus in a specific orbit, the orbits are also called as shells, and the electron possess the energy which is equivalent to the energy of that particular shell. So when we say that the electrons are present in the shell or orbit, how they are distributed in any atom? Now we are going to see the distribution of electron. Always remember, as per Bohr's atomic model, the electrons, they revolve in a stable shells, and those shells have a definite energy. So the shell which is nearest to the nucleus, it is called as the first shell, and the next shell is called as the second shell. Shells are named as, or they are referred as the symbols K, L, M and N. So the corresponding ordinal number of that shell will be 1, 2, 3, 4 of K, L, M, N respectively. Here you can see the K shell, its ordinal number is 1, L shell, its ordinal number is 2, M shell, its ordinal number is 3, N shell, its ordinal number is 4. Now when the electrons are distributed in the shells, they are distributed using one formula. You can see here the formula, that is the 2n square. N is the ordinal number here. So here we can keep the values in the formula. 2 into the first shell, it is K shell, so n is equal to 1, therefore 1 square. So the answer will be 2. That it means the first shell which is nearest to the nucleus of any atom, it may possess only 2 electrons in it. Then the L shell, its ordinal number is 2. So according to the formula 2n square, it will be 2 into 2 square. So The answer is 8. So the number of electrons they can get occupied by that shell will be 8. Then the M shell, the ordinal number 3, according to the formula 2n square, 2 into 3 square. The answer will be 3 square is equal to 9 multiplied by 2 is equal to 18. So here we can conclude that this M shell, which is the third shell, will contain 18 electrons in it. And the last shell, N shell, its ordinal number is 4. So according to the formula 2n square, 2 into 4 square. 4 square is equal to 16 multiplied by 2 is equal to 32. So the N shell, it may contain 32 electrons in it. Now we are going to see the electronic configuration of elements. Here you can see that some elements shown here like the hydrogen, helium, carbon, neon and sodium. You can see that the hydrogen, its atomic number is 1. Therefore, it contains 1 electron in its extranuclear part. As we know that the K shell is the first shell, so 1 electron it will get occupied in the K shell. So here you can see how the electrons will revolve in the hydrogen. Second is the helium. Its K shell will contain 2 electrons. As we know that the atomic number of helium is 2, therefore the electrons will get distributed in the first shell only. Now the carbon, its atomic number is 6. So K shell, it has the capacity to occupy 2 electrons only. 2 electrons will get occupied in a K shell, and the 4 electrons which remains will get enter into the second shell, that is the L shell. So the first shell will contain 2 electrons and second shell will contain 4 electrons. Likewise neon, it has the atomic number 10. So electronic configuration, we can see first shell will contain 2 electrons and second shell will contain 8 electrons. But in sodium, its atomic number is 11. So electron will get distributed like K shell 2 electrons, L shell 8 electrons and 1 electron will remain. It will get enter into the last shell, that is the M shell. So here we can determine that the electron distributed in the shells. Now here in this exercise we have to see how the electrons are distributed and we will write their electronic configuration. As we can see here, the first atom is hydrogen. Its symbol is H and its atomic number is 1. Therefore the K shell will occupy that 1 electron and its electronic configuration will be 1. Second element shown to us is the helium atom. So its symbol is He. Its atomic number is 2. Therefore the K shell will occupy 2 electrons. So its electronic configuration will be 2. Lithium, its atomic number is 3. 2 electrons will get occupied in a K shell and remaining 1 electron will get enter into the L shell. So electronic configuration is 2, 1. Always remember, a comma sign is given between the number of electrons which are occupied in the different shells. So here 2, 1 is shown as the electronic configuration. Now just we saw that the carbon, it possesses 6 electrons in it as its atomic number is 6. So electron will get distributed as 2 electrons in K shell, 4 electrons in L shell. K shell 2 electrons and remaining 4 into L shell. So electronic configuration will be 2, 4. Then the nitrogen, its atomic number is 7. So the 7 electrons will get distributed like the K shell 2 electrons and remaining 5 electrons in a L shell. So electronic configuration is 2, 5. Oxygen, atomic number 8, 2 in the first shell, 6 in the second shell. Therefore the electronic configuration will be 2, 6. Next atom is a atom of fluorine. Its atomic number is 9. Remember, electrons will get distributed 2 in the first shell, 7 in the second shell. So electronic configuration is 2, 7. Now look towards the neon. How the electrons are distributed in neon. So 10 is the atomic number. 2 electrons will go in the first shell and 8 electrons in the second shell. Therefore, electronic configuration will be 2, 8. In a sodium, atomic number 11, it will be 2, 8 and 1. So, electronic configuration will be 2, 8, 1. Then chlorine atom, its atomic number is 17. First shell will contain 2 electrons and 8 electrons will get occupied in a L shell and the remaining 7 electrons will be in M shell. So electronic configuration is 2, 8, 7. Look towards argon carefully. 18 electrons are present in it. So 2 electrons in K shell, then 8 electrons in L shell and 8 electrons in the M shell. So electronic configuration is 2, 8, 8. Now the bromine, its atomic number is 35. So 2 electrons in the K shell, 8 electrons in the L shell, K is fulfilled, L is fulfilled, 18 in the M shell, that means M is fulfilled, and now count how many electrons are remained there. So the remaining 7 electron will get enter into the N shell, which is the outermost shell. So electronic configuration of bromine will be 2, 8, 18, 7. So now you can determine the electronic configuration of all the atoms which you know. You have to remember the atomic numbers of all the elements and then you can determine the electronic configuration of any atom. Please look at the electronic configuration of neon and argon carefully. How many electrons are present in the outermost shell of neon and argon? So you will observe that 8 electrons are there in the outermost shell. Well, this information will be important for us in the next video, that we are going to see what it means by the valency and how the valency is determined. So here we will stop. We will visit in a next video. Please watch the next video and subscribe our channel. Thank you. Thank you very much.